Hello, I'm Subhash Talluri, and welcome to our demo on on-device SLMs for hyper-personalized customer experiences.
My name is Awais Khan. I'm a Principal Solutions Architect at AWS.
So today we're going to talk about on-device SLMs. So on-device could mean far edge and near edge. For our demo, we'll be talking about far edge, where we have SLMs deployed on a residential gateway and a mobile phone device as well. So let's start with the business challenge first. Today, if you look at any operator, 50% of the calls are related to billing inquiries, payment inquiries, or knowledge-related inquiries. So what we want to do is deflect all of those calls by handling inference to those such routine queries on the device itself, which is the mobile phone and the residential gateway. So by way of doing this, we want to reduce the excessive overhead that is on the cloud contact center and improve the latency and lower the bandwidth usage using small language models. So our solution brief, we'll be discussing about on-device SLMs. We have agentic orchestration that is done on the device, which knows how to uh, orchestrate between cloud and when to hit the device for inference. And the third aspect is the hybrid edge cloud inference. So we handle the simple queries locally, while complex queries that require automation or handoff to a downstream workflow will be handled in the cloud.
In terms of the solution architecture, this bottom layer basically depicts what's happening in the residential gateway, or any kind of customer premise equipment, right? Which is represented in this particular demo by this box that you see over here. This box has a 5G modem and also has a Wi-Fi access point. So these devices that you see on the table are attached to this device through Wi-Fi access, and then it has a backhaul of a 5G that is shown here. Now, what's happening is on the device we have the capability of doing edge inferencing through Intel, which is shown over here, and then these small language models are maintained by AWS IoT, as you see, and then the agent is basically making the decision whether this query can be solved locally or it has to go through to the cloud for inferencing. And then in terms of connectivity between the residential gateway and the cloud, we have a site-to-site VPN that is running. That basically handles all the data coming from generated from the device, and it's going back to the cloud. In the cloud, as you can see, there is AWS IoT, which is used to manage the small language models on the edge, and it has Bedrock for all the complex queries that are coming in, and it answers over there.
So let's now talk about the demo workflow. So the experience is going to be off the mobile device handset of a mobile subscriber. And we have a multi-agent orchestrator that is running on the device. Based on the query, that's going to divert to either for a far edge inference on the router itself or do the inference on the edge, the mobile device. So there are three use cases that we're trying to demonstrate here. One is the case of Wi-Fi troubleshooting, where if the customer is connected to the Wi-Fi, we are doing a far edge inference. This can be along the lines of Wi-Fi troubleshooting. It can also be parental controls, device management, anything that where we can automate or improve the tasks that we do on the router itself, including set-top box, etc. On the right is the more common queries such as bill explanation, which we handle on the mobile phone where the device deployment, the LLM deployment is taking place. And any complex queries such as bill discrepancy is handled in the cloud, where the response, there can be a downstream automation that can happen to either hand off to a cloud agent or to enable any downstream automation workflow. So let's now go into the demo. As Awais was mentioning, we have our router which is sending syslogs every hour to the device, and the model that is deployed on the device is via AWS IoT. Now these are devices at a customer premises, which means every operator has millions of customers. The only way to maintain such deployment at scale for models is through AWS IoT Greengrass and IoT Core. In this device, we are deploying the model, the Llama 1B model, and the key differentiator here is using CPU inference. So if we put a GPU on a home router, that is going to really increase the cost. So instead, using the Intel's OpenVINO SDK, we are able to do the inference via distributed CPU cores. So that's what OpenVINO allows us to do. So the syslogs, instead of being sent directly to the cloud, they're all processed locally and summarized, and a copy of that summary is sent to the cloud for a customer level data aggregation. So as we look at the demo, there's common queries such as state of the network, devices connected, or how the signal strength is. These are all handled locally in the device. This is done through orchestration, the device agent. Orchestration is happening on the mobile device, and that is doing planning tasks. The planning task is done through a cloud call through the Bedrock API, and the actions of that planning is executed locally. So in the second case, if a customer has a question about if they wanted to know more about their previous bill, so this is the case where the inference is happening on the mobile phone. In order to enable that, we have aggregation of data coming from multiple channels. So billings, payments, usage, all these different customer touch points are aggregated in the cloud through a batch process, run through a Bedrock API, and they're summarized into rich text and stored in a NoSQL database such as MongoDB. At the customer level, this is stored in the edge hardware. Because of the smaller footprint at the customer level, the size of that is at the order of kilobytes. So that is what is synced across all the devices, whether it is the router or the phone. Once we have the inference on through the mobile device itself, there can be another workflow where there is that of a bill discrepancy. If there's any downstream action that is required in order to process a refund or send it for escalation to a cloud to a contact center agent, that is going to happen through the cloud. Here the orchestrator is going to send that to a cloud agent. We have the cloud agent set up in the cloud that is connected to Bedrock agents that will enable any type of downstream automation that may be required. So we are now seeing response coming from the cloud. In true essence, this is it's a hybrid multi-cloud inference that's enabled by multi-agent orchestration. So the extension of this is the common queries that we are handling on the mobile phone that can be extended through any type of channels. It could be voice channels or chat channels enabled by Alexa, for example. The cloud inference could be extended to connection to Amazon Connect, where it can do a handoff to the agents through Connect.
As Subhash was explaining, the applicability of this solution is for many industry verticals. As you can see, this can be a smart residential gateway or a commercial customer premise device, things like on factory floor connectivity needs, and also on the edge devices as these small phones as well, right? So the applicability is pretty broad, but the concept remains the same, like how we are doing edge hybrid inferencing between edge and the cloud. So in terms of the key takeaways for this solution, the key idea is that we are enabling some of these devices that are on customer premise to become more smarter. Instead of answering the customer queries based on user guides, etc., these devices are now capable to actually learn from the real-time syslogs and being able to answer the queries locally rather than going to the cloud. So yeah, thanks for watching this video about our edge solution around Edge SLM, how we are enabling these devices on customer premise to become more smarter to solve some of the customer challenges from the operator side. Thank you.